In the summer of 1944, deep in the hedgerows of Normandy, a lone radio operator crouched in a muddy ditch while his comrades laughed at the contraption strapped to his back, a modified bicycle generator, the kind of thing you'd see powering lights at a village fair, not something meant for actual combat. The sergeant major had called it a bloody carnival toy just 3 hours earlier. The tank crews rolling past hadn't even bothered to look twice. But as German artillery began raining shells on the stalled American advance, and as hidden concrete bunkers spat death from positions no reconnaissance had detected, that bicycle generator would become the only lifeline between trapped infantry and the guns capable of saving them. If this is the first time you're hearing about the improvised radio equipment that changed battles in the Second World War, you're going to want to stay with us. Hit that subscribe button and the bell icon right now, because this story goes places you won't expect. Now let's get back to that ditch in Normandy. The story actually begins much earlier, in the workshops of a small British organization that officially did not exist. The Special Operations Executive, formed in July 1940 at Winston Churchill's direct order to set Europe ablaze, operated from offices on Baker Street in London. Their agents, soon nicknamed the Baker Street Irregulars, needed equipment that conventional military minds would never design. Equipment for sabotage, for guerrilla warfare, for transmitting intelligence from behind enemy lines where there were no power outlets, no reliable batteries, and no second chances. The problem was simple, but deadly. Radio transmitters needed electricity. In occupied France, in the mountains of Yugoslavia, in the jungles of Southeast Asia, electricity was either unavailable or too dangerous to use. A light flickering in an abandoned farmhouse at 2 a.m. meant Germans kicking down the door by 3. So SOE's technical branch went to work. They developed suitcase radios small enough to hide in luggage, powerful enough to reach London from deep inside Nazi territory. The Type 3, Mark II, became the most common set used by clandestine operatives between 1943 and 1945. It could send Morse code over 500 miles. It fit into a container small enough to parachute to agents in airtight drops. But it still needed power. The solution came from an unlikely source. In Australia, an engineer named Alfred Traeger had already solved a similar problem for doctors in the outback. He built transceivers into wooden boxes and attached bicycle pedals to drive small generators. The Royal Flying Doctor Service used them to keep remote stations connected across vast distances where power lines never reached. The concept was brilliantly simple: human muscle converted to electricity, no fuel required, no battery to die at the worst possible moment, just legs pumping and current flowing. SOE adopted and adapted the design. The result was the Admiralty pattern 323A pedal generator, a device that looked absurd and performed miracles. Resistance fighters across Europe attached bicycles to these generators and powered their radios by pedaling. In barns and basements, in forests and farmhouses, agents sent intelligence to London while a companion pumped the pedals like their lives depended on it. Because they did. Virginia Hall knew this better than most. She was an American who refused to let a wooden prosthetic leg stop her from becoming one of the most effective spies of the entire war. The Gestapo called her the most dangerous Allied agent in France. They hunted her relentlessly. She transmitted from attics and outbuildings while German direction-finding trucks prowled the roads outside, triangulating signals, closing in. Every transmission was a gamble. The Germans knew someone was broadcasting from the region. They just couldn't catch her. Hall would later become the first woman to receive the Distinguished Service Cross from the OSS, the American Intelligence Service that recruited her after she escaped France by crossing the Pyrenees on foot in winter, with that wooden leg, through mountains. But the bicycle-powered radio wasn't just for spies. By 1942, British naval commandos were landing on hostile beaches with pedal generators strapped to their backs. William Derrick Gilding went ashore at Oran during Operation Torch with a pedal generator and a signal lamp, setting up communications between the beach and supporting ships offshore. He waded through the surf carrying what looked like exercise equipment while Vichy French positions engaged the landing force. The covering fire he called in from the Warwick Castle helped break resistance on the beach. Now consider what happened in Normandy 2 years later, when Allied forces hit walls of resistance they hadn't anticipated. The bocage, that nightmare landscape of ancient hedgerows and sunken lanes, turned every field into a potential ambush site. German defenders had spent months fortifying positions. They built concrete bunkers into the bases of hedgerows, perfectly camouflaged, invisible from the air, and nearly invisible from the ground, until they opened fire at point-blank range. American tanks burned. Infantry pinned down in ditches, watched their comrades fall, and couldn't identify where the fire was coming from. Standard procedure called for forward observers to direct artillery onto enemy positions. These were highly trained men, usually junior officers with small teams, who pushed forward with the infantry and used radios or field telephones to relay coordinates back to the Fire Direction Center. The FDC was the brain of the artillery battalion, combining radio operators and human computers, who translated target requests into the precise range and azimuth data gunners needed. The system worked beautifully when it worked at all. But in the hedgerows, phone lines got cut by shell fragments within minutes of being laid. Radio batteries died. Sets got smashed, soaked, shot. What do you do when your equipment fails and men are dying? You improvise. And improvisation in Normandy sometimes meant scrounging bicycle parts from bombed French villages and jury-rigging power supplies for damaged transmitters. It meant requisitioning civilian bicycles meant for a completely different purpose and strapping them to SOE generators that were never intended for frontline combat. It meant looking ridiculous while doing something that might save lives. The Germans had their own bicycle-powered radios. Photographs from 1917 show communication squads behind the Western Front using tandem bicycles to drive generators that powered field wireless stations. Both sides had recognized decades earlier that human power was reliable in ways batteries simply weren't. The Germans industrialized the concept. They produced sophisticated GG 400 pedal generators capable of delivering both AC and DC current, built into trailers that could be towed behind vehicles or operated from fixed positions. The technology was proven. What mattered was whether you had it, when you needed it. In the bocage, Allied forward observers found themselves in a brutal cat-and-mouse game with German bunkers. These weren't the massive Atlantic wall fortifications the planners had feared. They were smaller positions, often constructed by local labor under German supervision, built to take advantage of terrain features and concealed with extraordinary skill. A bunker might be invisible until you were close enough to see the gun muzzle. By then you were dead. The only way to eliminate these positions was artillery, and calling artillery required communication. The SCR-299 was the workhorse of American military communications in the European theater. This mobile unit had proved itself in North Africa, where General Eisenhower credited it with enabling his reorganization of American forces after the disaster at Kasserine Pass. The SCR-299 could reach over 2,000 miles under favorable conditions, establishing contact between beach-landed forces and bases far to the rear. But it was a large unit, mounted in trucks, designed for battalion and regimental command posts. The forward observer crouching in a ditch needed something smaller. He needed the SCR-300, the portable backpack radio that weighed over 30 pounds and drained batteries like a thirsty horse at a trough. When batteries ran out, observers sometimes fell back on field telephones and miles of wire. A typical Corps artillery battalion would send forward observers with a radio, a telephone, and 2 miles of wire. They would string the wire as they moved forward, unspooling it behind them like a lifeline. But artillery fire cut that lifeline. Enemy patrols cut it. Sometimes the wire just broke. And then you were silent, watching shells fall on friendly positions you couldn't warn, watching bunkers fire on infantry you couldn't help. This is where ingenuity became survival. Forward observation teams learned to scrounge anything that could extend their effectiveness. The British had been training their agents and commandos with pedal generators for years. When American units operated alongside British forces, technology crossed lines of communication. A generator meant for an SOE radio could power an American transmitter if you knew how to rig it. A bicycle abandoned by fleeing civilians could become the solution to a problem no one in Washington had anticipated. The mathematics of human-powered generation were surprisingly favorable. A healthy man pedaling at a moderate pace could generate around 50 to 70 watts continuously. A radio transmitter needed steady power, not the surge a hand-cranked generator produced. Pedaling was smoother, more sustainable, easier on equipment. Two men taking turns could maintain power for hours. The SOE had proven this in operations across occupied Europe. Now the concept proved itself in combat conditions nobody had specifically planned for. Picture the scene in a Norman field. An observation post has been established in a ruined farmhouse perhaps 400 meters from suspected German positions. The two-man team has their SCR-300, but the batteries are dead, killed by heat and humidity and constant use. They have a captured German telephone, but the wire back to battalion was cut somewhere in the last barrage. They can see movement near a hedgerow. They're certain there's a bunker there. They watched a Sherman tank brew up trying to push through an hour ago. The crew didn't get out. One of them remembers seeing a bicycle generator at a supply point the day before, brought forward for some signals unit that never arrived to claim it. It's a British model meant for powering Morse code sets. The power output isn't quite right. The connectors don't match. But there's a man in the observation team who worked at a garage before the war. He knows how current flows. He knows wire. In 40 minutes of cursing and improvisation, stripping wire from the useless field telephone using a pocket knife and hope, he rigs the generator to the radio's power input. Now someone has to pedal, and keep pedaling, while the observer watches, while coordinates are calculated, while the Fire Direction Center receives the transmission and computes the solution, while firing orders go to the guns, while shells leave tubes and arc through the sky. All that time, someone has to keep those legs moving, keep the current flowing, keep the radio alive. It's exhausting, it's absurd, and it works. The first rounds fall short. Standard procedure, fire for effect is too dangerous without registration. The observer corrects, adds 200, keeps watching. Second volley, closer, now right 100. The shells are walking toward the hedgerow. The man on the bicycle is gasping, but he doesn't stop. A third correction. Fire for effect. High explosive shells slam into the position. Earth and concrete and vegetation erupt skyward. When the smoke clears, there's a crater where the bunker was. The gun that killed the tank crew is silent. The infantry can advance. This was not an isolated incident. Across the Norman battlefields, improvisation was constant. The official histories don't always capture it, because improvisation doesn't fit neatly into unit records and after-action reports. But veterans' accounts are filled with moments when standard equipment failed and creative solutions emerged from desperation. The bicycle-powered radio was one such solution, born from British clandestine operations and adapted to frontline necessity. The Jedburgh teams that dropped into France before and after D-Day understood the importance of reliable communications better than almost anyone. Each three-man team, typically comprising an American officer, a British officer, and a radio operator, jumped with their Jed-set radios and the knowledge that silence meant death. They worked with resistance groups, arranging airdrops of weapons and supplies, coordinating guerrilla actions with the advancing Allied armies. More than 90 teams parachuted into France in 1944. Many dropped blind into territories where communication with London had gone dark. Their first priority on landing was always establishing radio contact. Everything else depended on it. The Jet Set was specifically designed for clandestine operations. It was smaller than standard military radios, lighter, more portable, but it still needed power. And in the chaos of operations behind enemy lines, power was never guaranteed. The resistance fighters who received these teams were often already using bicycle generators to power their own equipment. They taught the American and British officers who dropped to them. Knowledge flowed both ways across the lines. The tactical value of what the Jedburghs accomplished cannot be overstated. They helped resistance groups clear entire departments of German soldiers before regular Allied forces even arrived. They called in airstrikes. They coordinated sabotage of rail lines and bridges. They reported enemy positions and movements. All of this required radio communication. All of this sometimes depended on someone pedaling a bicycle connected to a generator, while German patrols searched for the transmission source. Consider the technology for a moment. In 1944, the cutting edge of military communication was vacuum tube equipment, sensitive to vibration, heat, and moisture. These radios were magnificent achievements of engineering, but they were also fragile. They could break from a hard drop. They could fail from condensation forming inside the chassis. They could go silent when a single tube cracked. Against this fragility, the bicycle generator was robust, almost to the point of absurdity. It had no tubes to crack, no capacitors to fail, no delicate circuits to short. It was mechanical, simple, and nearly indestructible. You could drop it from an airplane, and it would probably still work. The worst that could happen was a thrown chain, and any soldier who'd grown up with bicycles could fix that in minutes. There's something profound in this. The most sophisticated weapons of the war, the artillery pieces capable of throwing shells miles with devastating accuracy, depended ultimately on information. Without forward observers, without communication, those guns were just expensive noise. And the communication systems that fed them information could fail in countless ways. The bicycle generator, that laughable contraption, was often the backup that made the system work when everything else broke down. The psychological dimension deserves attention, too. Soldiers mocked the bicycle rigs. Of course they did. In a military culture that celebrated tanks and planes and heavy guns, a bicycle looked ridiculous. But mockery evaporated quickly when the alternative was silence, when silence meant death, when the only thing standing between your platoon and annihilation was a ridiculous contraption that actually worked. There's a special kind of respect that develops for equipment that saves your life. It doesn't matter what it looks like. It matters what it does. After Normandy, the improvised use of bicycle generators became more common as advancing armies encountered the same problems with power and communication. In the dash across France, units outran their supply lines. Batteries were always in short supply. The French resistance had been using bicycle-powered equipment for years, and they shared both equipment and expertise with the soldiers liberating their country. In some cases, entire networks of resistance radios were integrated into military communication systems as faster and more reliable than anything the military could establish from scratch. The liberation of Paris in August 1944 was coordinated in part through these networks. Resistance fighters who had survived years of German occupation, who had transmitted intelligence while pedaling furiously to keep their radios alive, now guided Allied forces through streets they knew intimately. The coordination between regular military units and resistance forces was imperfect, sometimes chaotic, but it worked. And it worked because communication worked. Because men and women had kept those signals flowing no matter what it took. Moving east toward Germany, the terrain changed, and so did the challenges. The Siegfried Line presented fortifications far more formidable than anything in Normandy. Concrete bunkers with interlocking fields of fire, dragon's teeth anti-tank obstacles, dense minefields. Breaking through required massive artillery support, and massive artillery support required accurate observation and reliable communication. Forward observers operated under constant enemy fire, often exposed, frequently wounded or killed. Their radios were priority targets for German snipers who understood exactly how dangerous a functioning American radio could be. Replacement equipment was never as available as planners assumed it would be. Radio sets were manufactured on the other side of the Atlantic, shipped across submarine-infested waters, unloaded at ports that were themselves under repair from German demolitions, trucked forward through supply lines stretched thin by the rapid advance. Every radio that broke in combat might not be replaced for weeks. Every battery that died meant finding alternatives. The winter of 1944-1945 was brutal. The Battle of the Bulge began in December with German forces smashing through thinly held American lines in the Ardennes. Communication collapsed in the initial chaos. Units were overrun before they could transmit warnings. Radio silence protocols meant some commands had no idea what was happening until German tanks appeared in their rear areas. Forward observers died at their posts, still trying to call in fire missions that would never be completed. In the chaos, improvisation again proved critical. Units that had adopted non-standard equipment, that had learned from the British and the Resistance and their own bitter experience, sometimes maintained communication when others went silent. A bicycle generator might be the difference between calling for help and dying without anyone knowing where you were. Survival favored adaptability. The Battle of the Bulge was eventually won by a combination of factors: massive reinforcement, heroic defense at places like Bastogne, and the simple fact that German logistics couldn't sustain an offensive in winter conditions. But communication played a role at every stage. Troops who could report enemy movements helped commanders understand a situation that initially seemed hopeless. Artillery that could be directed onto German columns slowed advances that might otherwise have been unstoppable. The primitive bicycle-powered backup systems that had seemed like jokes were anything but. As the war moved into Germany itself in 1945, the bunkers became more numerous and more formidable. Hitler's final defense zones included fortified towns, industrial complexes turned into fortresses, even the famous but overrated Alpine Redoubt. American and British artillery expended millions of shells reducing these positions. Every shell required targeting. Every target required observation. Every observation required transmission. The human cost of forward observation was staggering. These men operated at the sharp point of combat, closer to the enemy than anyone except the assault infantry. They were targeted specifically because they were recognized as high-value assets. German doctrine emphasized killing observers because silencing them meant silencing the guns that truly terrified German defenders. The life expectancy of a forward observer in heavy combat was measured in days or hours, not weeks. Despite this, men volunteered for the duty. They understood the mathematics. An observer who called accurate fire saved more lives than he risked by his presence. Artillery that landed on enemy positions was artillery that didn't land on friendly troops who might have walked into ambushes. The observer was force multiplier and protector combined. His radio was his weapon, and whatever powered that radio was his ammunition. The final campaigns of the European War saw Allied communication systems operating at unprecedented scale. Hundreds of artillery batteries coordinated through fire direction centers that processed information from thousands of observation posts. The system was robust, redundant, designed to continue functioning even when parts were destroyed. But it still depended on forward observers with radios. It still sometimes depended on improvised power supplies when standard equipment failed. Victory in Europe came in May 1945. The bunkers that had seemed so formidable were rubble. The German army that had conquered most of Europe was shattered, surrendered, disarmed. But the lessons learned in defeating that army would echo through the decades that followed. Communication was decisive. Artillery was devastating, but only when properly directed. Improvisation could bridge gaps that planning could not anticipate. The bicycle-powered radio passed into military history as a footnote, rarely mentioned in popular accounts of the war. The glamour went to tanks and aircraft, to bold commanders and desperate stands. But those who fought knew the truth. The war was won by systems, and systems depended on communication, and communication sometimes came down to a man on a bicycle pedaling furiously while shells burst nearby. After the war, technology advanced rapidly. Transistors replaced vacuum tubes. Batteries became more powerful and reliable. Satellite communication eventually made the problems of 1944 seem almost quaint. Modern forward observers carry equipment that would seem like science fiction to their predecessors. Digital radios linked to GPS satellites, laser rangefinders, direct data links to aircraft, and artillery computers. But the fundamental principle remains unchanged. Information must flow from those who can see to those who can shoot. Any break in that chain costs lives. Military historians have debated for decades what mattered most in winning the Second World War. Some emphasize industrial production, the sheer weight of American and Soviet manufacturing overwhelming German and Japanese capacity. Others point to intelligence breakthroughs, the code breaking at Bletchley Park and the American penetration of Japanese communications. Still others focus on command decisions, the choices made by Eisenhower and Marshall and Roosevelt that shaped the strategic conduct of the war. All of these factors mattered. But at the tactical level, in the fields and forests where men actually fought and died, what often mattered most was whether a radio worked, whether a message got through, whether artillery fell on the enemy instead of on friends. The bicycle-powered generator that kept those radios alive during critical moments deserves its place in that history, not as a wonder weapon, not as a technological marvel, but as a tool that worked when it was needed most. Virginia Hall survived the war and joined the newly formed Central Intelligence Agency, serving until her retirement. Her wooden leg and her bicycle-powered radio transmissions became legend within the intelligence community. The Jedburgh veterans went on to found Army Special Forces, carrying forward the lessons of unconventional warfare they had learned in occupied France. The forward observers who survived the Bocage and the Ardennes and the final push into Germany came home carrying memories of improvised solutions that had saved their lives and the lives of the men around them. The men who laughed at the bicycle rig learned to stop laughing. Some of them learned because the bicycle rig called in the fire that broke open the bunker that had their platoon pinned. Some learned because the bicycle rig was the only thing that kept working when everything else failed. Some never learned at all because they didn't survive to understand what had happened. In war, what looks foolish often proves wise. What seems improvised often proves essential. The institutions and armies that win are those capable of adaptation, capable of taking civilian technology and military technology and combining them in ways nobody planned. The bicycle-powered radio was exactly that kind of combination. It came from Australian medicine and British espionage and American desperation. And it ended up directing artillery on two bunkers that would have cost hundreds of lives to take any other way. That's the story of the bicycle-powered radio that called artillery on hidden bunkers. Not a story of a single genius or a single innovation, but a story of systems and adaptation, and the thousand small decisions that accumulate into victory or defeat. The soldier who first strapped a bicycle generator to an American radio set didn't know he was making history. He was just trying to stay alive and do his job. But what he did mattered. The shells fell, the bunkers burned, the war moved forward. The next time you see a bicycle, Remember that one of them helped win the Second World War, not by carrying a soldier into battle, but by powering the radios that brought destruction down on enemies who thought they were safe behind concrete walls. In the end, it wasn't the size of the weapon that mattered. It was whether you could tell someone where to point it, and sometimes telling them required legs pumping on bicycle pedals while the world exploded around you. That's what won wars. Not just courage, though courage was required. Not just firepower, though firepower was decisive. But the connection between them, the communication that turned individual bravery and industrial might into coordinated victory. The men who made those connections, often with improvised equipment and desperate ingenuity, deserve to be remembered. They changed the course of battles with information more powerful than any single shell. They saved lives by risking their own. And sometimes they did it on equipment that made their comrades laugh, right up until the moment it saved everyone's life. That's the truth about war that the histories often miss. It's not just about the weapons you're issued. It's about what you do when those weapons fail. It's about adaptation, about creativity, about refusing to accept that silence is the only option. The bicycle-powered radio wasn't in any official equipment list. It wasn't taught in any school. It emerged from necessity, from the desperate need to communicate when communication seemed impossible. And it worked. Against all expectations, against all mockery, against all odds, it worked. The shells fell on the bunkers. The infantry advanced. The war was won in part by men pedaling bicycles while shells burst around them. Remember that the next time someone laughs at your improvised solution. Remember the bicycle radio that called artillery on hidden bunkers. Remember that what works matters more than what looks impressive. Remember that wars are won by soldiers who adapt, who overcome, who refuse to be silenced no matter what it takes. That's not just a lesson about military history, it's a lesson about everything. Adaptation wins. Improvisation saves lives. And the people who laugh at you before you succeed are often the ones cheering loudest after. The bicycle radio is forgotten now, a footnote in military archives, a curiosity in a few museums. But the principle it represented lives on. The connection between information and firepower, between observation and destruction, remains the foundation of modern military doctrine. Everything else is refinement. The core truth was demonstrated in the hedgerows of Normandy by men who understood that a working radio was worth more than a dozen broken ones, no matter how ridiculous the working one looked. They didn't fight for glory. They fought to survive, to complete their missions, to bring their friends home alive. The bicycle radio was just a tool, but it was the tool they needed when they needed it, and that made all the difference. History remembers the generals and the grand strategies. But the battles were won by sergeants and lieutenants and private soldiers who figured out how to make broken systems work, who scrounged parts from destroyed equipment and bombed villages, who pedaled bicycles while calling fire missions, who did whatever it took because the alternative was unacceptable. Those soldiers are mostly gone now, passing into memory with each year, but their legacy remains in the military forces that absorbed their lessons, in the doctrine that emphasizes communication and flexibility, in the training that prepares soldiers for situations that no one can fully anticipate. The bicycle radio was part of that legacy. A small part, perhaps, but a part that mattered. And that's the story, not just of one incident, but of a way of fighting that proved decisive. The bicycle-powered radio that called artillery on hidden bunkers is a symbol of something larger, the triumph of adaptation over planning, of ingenuity over doctrine, of determination over despair. They laughed at the bicycle rig. They stopped laughing when the bunkers burned.